I'm a professional mathematician and I'm going to show you how to calculate this integral in 2 minutes. So here we have 1 over root x times x plus 1, and there isn't any obvious u substitution here, or so it seems. But what we can do is we can do the following, and this is a trick, is we can take u to be such that u squared equals to x. Okay, so that's how a u substitution. What happens when you take du? So if we differentiate both sides with respect to x, we eventually get the following expression, 2u du is equal to dx. Okay, so what this does is it replaces dx in terms of some expression of u and du. So it's not like saying u is a function of x. It's x is a function of u. So we get this expression which just allows us to directly replace the dx and not look at any term times dx to replace with du, as usual with u substitutions. And the second thing is it gets rid of the square root, which is a bit pesky for us. So let's just dive into that. So we get integral of 1 over the square root of x, right? The square root of u squared times x plus 1. So x plus 1 is going to be u squared plus 1, and this is going to be multiplied by dx, which is going to equal to 2u du. Okay, that's what it's going to be. And now you see something cool. The square root of u squared is going to be u, and that's going to cancel with the u up top. Okay, so we're going to get the integral of, so we're going to get 2 times, I'm going to factor out the 2, integral of u over u times u squared plus 1 du, and that's going to equal to, once you cancel out the u's, it's going to equal to 2 times the integral of 1 over u squared plus 1 du, and that is a famous integral. You have to know this one. It's the arctan of u. Okay, so it's going to be 2 times the arctan of u, plus a constant, and of course we can substitute our u back in. Our u squared was x, so u was equal to root x. Okay, so that was another way of writing it out. So it's going to be 2 times the arctan of the square root of x plus a constant, and I encourage you to actually differentiate this and check that you do in fact get that answer. So that's an independent verification. Thanks so much to Alex and Nathan for their ongoing support on Patreon, and please consider supporting on Patreon if you're really enjoying my content and gaining consistent value from it. Small contributions really add up and make a huge difference for me to keep growing this channel, plus the exclusive perks for you. And now if you want to see more fun integrals, I've got 2 fun integrals for you. This one here, you're going to love it. It uses arctan as well. And this is another one you're going to love, and it's a very cool trick. It's another 2-minute integral. So check out either of them. I've got an integration playlist as well. Okay, so you can find that on the playlist tab of my channel. Hope you have an amazing day.